So let's say the instruction we're processing is a compare instruction. With a compare instruction, we're not interested in the number that is output by the ALU. We only want to know how the two inputs compare to each other. For that, we use the flags that we talked about earlier. Each flag is just a wire that turns on or off depending upon whether or not a certain condition is true. Inside the Scott CPU, there are 4 flags, and we'll look at 2 of them now. The A is larger flag will turn on if input A is larger than input B. If the inputs are the same, then the equal flag turns on, and if both of these flags are off, that means input B is larger. But in this case, the equal flag is on, so that means both inputs are the same. Once the compare instruction is over, we still need to use the flags for the next instruction, so we'll save them to a register that only has 4 inputs and 4 outputs, 1 for each flag. Once the flags are set into the flags register, the CPU is finished with the compare instruction, and it can then request the next instruction from RAM. Generally, the next instruction after a compare instruction is a jump if instruction. This combination of a compare and a jump if instruction, by the way, is very common in computer programming. Anytime there is more than one possible path through a program, the computer is using these instructions to tell it which way to go. So now that we're finished with the compare instruction and our flags are saved in the flags register, we need to tell RAM that we're ready for the next piece of data, in this case the next instruction. So inside the CPU, another register that is very important is what's called the instruction address register. The CPU uses this register to know where the next instruction should come from in RAM. When the CPU is ready for the next instruction, it enables the instruction address register onto the bus. Eventually, the instruction address will flow to RAM, but it doesn't get there directly. There is an intermediary register called the memory address register, whose only job is to tell RAM what memory address the CPU wants next, since it won't always be an instruction. Once the instruction address is set into the memory address register, it is automatically sent to RAM since the memory address register doesn't have an enable wire. The control unit then turns on the enable RAM wire, and RAM automatically sends back the data at that address, which in this case is an instruction. That instruction is then saved in the instruction register, and the control unit begins processing it. In this case, it's a jump if equal instruction, which checks to see if the equal flag is on.